equipment with you, and that you are able to start straight away on the do now. Okay, so we're solving for the unknown for x. All right, so this is a typical grade 10 question. So please get started on that in the meantime, and as soon as everybody's here, we'll mark the do now and then we'll move on. Hello, Marisa. Nice to see you again. Welcome. Please get started on the do now. All right, and then as soon as everybody's here, then we'll get underway. Okay, so glad you joined us. All right. Tula, Mpuenhle says that he can't hear anything. Hi, Tatuka. How's it? Can you hear me okay?
Yes, I can, ma'am.
Oh, brilliant, Tatuka. Okay, that's awesome. No problem. Okay, I just wanted to double check because a couple of people are saying that they can't hear. Okay, so Mpuenhle can't hear for now. Tatuka, get started on the do now in the meantime, please. Thank you. And then we will carry on with our lesson thereafter. Nhlafatso, I hope you can hear me okay. Mpo says he's struggling. Okay, so hopefully everybody's working on the do now and we can get going in a couple of minutes. All right. Hi, Angel. Hi, Angel. I hope you can hear me. Can you? That's an awesome smile. Okay, Angel. So if you recall from last time, please get started on the do now. Okay, and then we're going to get underway shortly. All right. Oh, there's a whole lot of other people here. Oh, very nice. Okay, so hello, Zayan. Hello, Tandeka. Hello, Zanele. Hello, Inam. Hello, Faith. And then Harrison, I don't remember from last time, but anyway, hello to you as well. Narcisa, welcome to you. So I hope I've greeted everyone. Okay, so we're just having a look at the do now. We're going to work on that for another minute or so, and then we'll start talking about the answers. If you can't hear, please type a message in the chat and let us know so that Tula and I can sort that out for you. Otherwise, I'm just working under the assumption that you can hear me, and I hope you all can. Okay, well, everybody should be here by now. All right, and hopefully I've given all of you an opportunity to be able to at least do one of the do now questions. Is there anybody who's been able to do both of them, the purple one and the green one? Anyway, you can chat to me or you can unmute your mic. Anybody been able to do both? On Thatilia, I see you here with us again. Hello, welcome. Okay, so now am I assuming that we haven't been able to do two? Has anybody been able to do the green one successfully? If you can send me a thumbs up or yes me or something like that. Or are these really, really difficult? Okay, so unfortunately, I'm not seeing any messages from any of you. Okay. All right, so grade 10s, if you can please just chat to me, that would be awesome. Can you let me know if you were able to do the green one? Even if you can't, it's not the end of the world. Don't stress. I will go through these with you, but I just wanted to make sure that you were able to do it. Was anybody able to do the green one? Or was it far too difficult? Ma'am, I'm not done. Okay, that's fine. You struggling, Zayon. Okay, all right, that's fine. Thank you for replying to me. Okay, so my apologies, grade 10s. I didn't want these to be something that when you started the lessons that this was going to be something that was really, really difficult for you. That's not the idea at all, okay? I wanted you to be able to look at this and say, yes, I know exactly what it is that I'm supposed to do. Okay, so in grade 10, one of the things that changes from when we're in grade 9 is that we learn to start solving for x when x has an exponent that isn't 1. Okay, so just stop what you're doing for now and just listen to what I'm saying and I'll help you through these questions, okay, because these are going to be important for you later on anyway. So up till now, all right, so grade 8, grade 9, we were given equations that looked like this. All right, so let me just get my pen and I'm going to make one up. So for example, 2x plus 1 is 9. Okay. Now, when we solve for an equation like this, what we don't know at the time when we're doing it, but what is very true, is that that x has an exponent. And I'm going to try and make the exponent a nice bright color. It's to the power of 1. So these are called linear equations. And they only have one answer. There's only one answer that x can be in order to make the left-hand side equal to the right-hand side. So if we were solving a linear equation like this, what we would have been taught to do is to isolate the 2x, take the 1 over to the other side. We would end up saying 9 minus 1. That would give us 8. And 2 times what number gives us 8? Does anybody want to type into the chat for me? What should I say x is equal to?
4.
4, brilliant, absolutely. And how did you get that answer of 4?
8 divided by 2.
Exactly, 8 divided by 2, lovely. Okay. Marisa, you okay? Do you need to ask a question? All okay? All right. Now, the equation that I have given you is completely different, okay? This is not a linear equation, okay? This is a quadratic equation, and we can't solve them by what we did with linear equations. The only way that these can be factorized is by, can be solved is by factorizing, Okay, so you have to be able to factorize that trinomial. All right, so now the trinomial in this case, I'm going to do it down here, is, let's just get the right color. The trinomial is x squared plus 2x minus 15 equals 0. Right? So now, what we want to do when we see that it has a power of 2, that's what changes everything for us. We see that x is to the power of 2. So straight away, that means that we have to have all the terms on one side, in this case, the left-hand side, and it has to be equal to 0. And the next thing that we need to do is we have to factorize. Okay, so we are going to factorize this trinomial. Because it is a trinomial, it factorizes into how many brackets? Tutuka, can you tell me how many brackets it needs to factorize into? Do you know?
2, ma'am.
Exactly, Tutuka, quite right. And Inam said 2 and Harrison said 2. Perfect. It needs to have 2 brackets. Now, Tutuka, you gave me such a nice answer. I'm going to ask you if you can tell me what needs to be inside these 2 brackets. What's the first thing I need to write in this bracket and the first thing I need to write in that bracket? There where I put those dots. Ah, Nazol. All right, you've written that down. Lovely. Okay, so Nazol says that in this bracket, we need to write x plus 5. And in this bracket, we need to write x minus 3. That's how we factorize. So if you recall, we are doing the opposite of FOIL, right? So we have got terms, we've got an algebraic equation, we are putting the brackets back in. Okay, so now what Nazol is saying to us is this. She's saying that if we multiply, let's get a different color, x with x, we're going to get our x squared. If we multiply positive 5 with negative 3, we're going to get our negative 15. How do we get this plus 2x in the middle? That comes from multiplying x with minus 3 and 5 with x. Okay, so if I'm sitting at minus 3x on the number line and I add 5x, then I'm going to end up at minus 2x. So well done, Nazol, that's perfect. All right, so I have to factorize. So now, Nazol, either x plus 5 is 0, in which case x is equal to negative 5, or x minus 3 is 0, in which case x is equal to what? Kelebochile, can you tell me? Kelebochile, I hope you can hear me. Do you know what x needs to be equal to? If you don't stress. Minus 5, well done, Angel. That's right. So the one answer is minus 5. Now there has to be perfect. All right, well done. So Nazol says that the other answer has to be x equals 3. Well done. All right, so now really important for us in grade 10, we have to be able to factorize. And then from that process, we have to be able to write down our answers. Okay, we've got to be able to do that in grade 10. Is this something that you feel that you need a little bit more practice with? If you think yes, then you can type yes into the chat. If you feel no, then say no. But we're going to need to be able to do this for the work that's going to be coming. Nosisa, yes. Yes, ma'am. Okay. Good question, Tutuka. Angel, no, that's fine, perfect. On Fatile, so yes, though I understand as we move. All right. Azoma, thank you. All right, thank you for your responses. All right, so now we need to get on with our lesson, but I do want to understand, I do want to answer Tutuka's question. Okay, so the idea is this, Tutuka, and anybody else who might have been feeling a little bit lost, is that after we have factorized, we have got, so let's just go back down here again. Okay, so Tutuka, we have factorized. We've got x plus 5 times x minus 3 equals 0. So if I have two things being multiplied together and my answer is 0, the only way I can get 0 as an answer is if one of my things is 0, isn't it? It's the only way, okay? So I have to multiply by 0 to get 0 as an answer. So Tutuka, either x plus 5 equals 0 or x minus 3 equals 0. Then what happens? Do you remember how here I took this plus 1 over to the other side and it changed its sign and it became a minus 1? I'm doing exactly the same thing over here. All right, so plus 5 is going over to the other side and it's becoming negative 5. Minus 3 is going over to the other side and it's becoming plus 3. Okay, does that feel a little bit better? I hope that that's made a little bit more sense to everybody, but yes, we can certainly see what we can do about, yes, okay, I'm so glad, Tutuka. All right, so we can see what we can do about that because, yeah, being able to factorize for us in grade 10 and going forward into grade 11 is super important. Okay, so now, do you remember our lesson from last week? And I hope you will all say yes. We spoke about if a graph has a happy face or if a graph has a sad face. Does everybody remember that? So thumbs up if you remember. Happy face and sad face. Cool, Zayan. All right, so I know you remember. That's great. I hope everybody else remembers this story. Okay, so now, if a graph has a smile, it has a minimum turning point, right? So now what we mean by that, okay, is this. Let me just move the chat out the way. Okay, everybody's got thumbs up. Okay, lovely. Okay, so in other words, our graph does that. Okay, so this value over here, this smallest value that it gets to is what is referred to as our minimum. That is the smallest y possible. Right? Then if we've got a graph that has a frown, okay, it looks like this. And here, this doesn't have a smallest because remember these numbers just keep getting smaller and smaller going in that direction. It has a biggest or a largest number that it reaches, and that is called its maximum. And that means it is its largest y or output value. Okay, do you recall from last week if we wrote that a is greater than 0, we are saying that a is positive. If we write that a is smaller than 0, we mean that a is negative. Okay, so something else that we're going to talk a little bit about today is about the words increasing, decreasing, and the words range as well. Now, hopefully your teachers at school have used these words with you before, but I'm going to go over it again and explain to you what it means. Okay, so now, before we get started, let's just get this over here, and I want you to tell me, does this graph that I'm showing you now on the board, does that have a maximum or a minimum?
Please repeat the question.
Sure. Does the graph that I've got on the board, does that have a maximum or a minimum? Good, Zayan, maximum. Sorry?
Maximum.
Maximum, you're both right. Well done. So this has a maximum because it's wearing a frown, okay? So it has a maximum value that it can reach. All right, now we're going to talk a little bit about what that means just now. once we have spoken about, oh, and actually, you know what, let's do it now, okay? Do you know what a domain and a range are? So you can type in the chat. Do you know what the word range means? Let's just start with that. Do you know what the word range means? Yes, Inam. Good. Okay, Nosiso, no. Fine, no problem. I'm glad I asked then. Okay, Zayan, you said yes. Anybody else? Naileti, you saying no? Okay, I'm going to write the word here. Does anybody else know? Marisa, let me just read what your comment says. Marisa, you think it means scale, okay? Nizol, range is Y, I think. Okay, now, well done, Nizol. Absolutely. Marisa, no worries, okay? At least you've provided an answer, which I think is really cool. But you're quite right, Nizol. Range means Y, okay? The Y values, right? So what's happening with this particular function, right, is that if I sit on the line and I sit over here and I move up in this direction over here, what's happening to Y? Is it getting bigger or is it getting smaller? It's getting
smaller, ma'am.
Getting smaller? Is Y getting smaller on this side? Okay, so imagine if this was us, all right? And I'll draw a picture of us. 100% Nasisa. Are we walking uphill when we walk in this direction? Are we walking uphill? Yes, we are. Okay, quite right. We are. We're walking uphill, right? So if we start down there and we end up walking up here, we are walking all the way. So it's like being in a basement. So imagine if we were down at level -3. Now we walked up to -2. Then we walked to -1. Now we're on ground level. Okay, now we're walking up inside the building. First, we go to the first floor, and then the second floor, and then to the third floor. And then once we get to the fourth floor over here, we've got to the top of the building. Okay, can we continue to climb higher? No, we can't. Okay, so we've reached the highest point, okay, when we are standing there. We can't go any higher. And if we don't start walking down the other side, then we're not walking downhill either. That's why this is called a turning point, because now our direction is changing. Instead of us walking uphill, we're now going to be walking downhill. So now, of course, we've got big smiles on our faces because now it's easy because we're all going downhill. Okay. So now back to this bit over here, all right? Remember we said that the biggest number that we could climb to would be this one over here. That happens to be 4 in this instance. So that means that for this particular function, the maximum is 4. Okay, that's our maximum. We cannot get any bigger than that. So every other number that is part of our range, 3, 2, 1, 0, -1, -2, -3, is going to be smaller than 4. So we'll write our range as follows. Y is smaller than or equal to 4. Is everybody happy with that? Okay. So when I am on this side over here, so this side, okay, I'm walking uphill. So this is where my graph is increasing. Now I'm happy. I got to the highest point, the turning point, and now I'm walking down this side over here. Sorry, it's very badly drawn by me. And now this is where I am now walking downhill. So this is where the function is decreasing. So this means Y is getting bigger. Y got to the biggest it can be. And now Y is getting smaller again. Remember, if you walk off down here, you're going to go back down to level 3, back down to level 2, back down to level 1, back down to the ground level. I hope that makes sense for everybody. Okay, so but these are important words that we are going to hear when we work with functions. Okay, so now these questions will come up in the quiz, they will come up in the papers that we're going to do. So that's why I wanted to have a discussion about that. But let's get on to what we really wanted to do. And that was to find the equation. Okay, so now we want to find the equation. We've been charged with finding the equation of this particular parabola. What that means for us grade 10s is that they want us to work out, all right, looking up here, they want us to work out the value of A, and they want us to work out the value of Q. Right? Now, we had a good discussion last week about what A and Q are and what they mean. Can somebody tell me from looking at the picture what the value of Q is? You can unmute yourself or you can type it into the chat. The choice is up to you. Can anybody tell me what Q is equal to? Wow,
4.
that was quick. Awesome. Well done. 100%. So, well done. Good. Good. Well done, guys. Okay, so that's great from last week. So that was equal to 4. So if they give you the value of Q in the diagram, like they have here, where they've told you the turning point or the y-intercept, that's what you do straight away, grade 10s. You write down y equals ax squared. And now we're going to replace plus Q with plus 4. Okay. What's the only other bit of information that they've given us? Well, we've already used this point over here. We've used that when we put the 4 in. The only other bit of information that we've got is this other point over here, B, 2 and 3. So that's B over there, 2 and 8 over 3, beg your pardon. Angel, Y4. No problem. Angel, when we write a parabola in the form y equals ax squared plus q, this q over here has a very special meaning. It only means one thing. And that q is there to represent the value of y at the turning point. Okay, so the value of y, in this case at the y-intercept, because your y-intercept and your turning point is the same. Yes, it's where the x-axis meets the y-axis, absolutely. Okay, so but it's this point up here. All right, so Q is equal to 4. If I have a look at another diagram, we're going to do this one next. Angel, let's just have a quick look down here. Okay, now this is completely different, right? What's the value of Q in this picture that I've just shown you?
-3, ma'am.
Perfect. Perfect. Okay, so most of the time that's going to be given to you, or if it's not given to you, there's going to be a way for you to be able to work it out. Okay, so that is the value of y at the turning point. Okay, wonderful. So now let's go back to this diagram over here. In order to work out, so now they want us to work out A and Q, right? So now we've got Q, now we need A. Can anybody tell me what you think I need to do here? Like, how am I going to work out what A is? I can't work with 3 unknowns in an equation. I can only have 1. So what am I going to do with this other bit of information that I've been given? Let's see if I can. Please don't be afraid. I will never, ever be cross with you. If you don't know, you can tell me you don't know. It's not the end of the world. Okay, so
is it fine to work out the gradient?
You're not going, unfortunately, with this graph, you can't work out the gradient because the gradient is constantly changing. So it's different to a straight line. In a straight line, you're going to work out the gradient because the gradient is constant. It doesn't matter where you are on the line. Gradient stays the same. But here, if you think about it, and I like that analogy of us climbing up a building or climbing a mountain. I mean, if you're climbing, let's say you're down here All right. Is it steeper here than it is there? It's steeper here, and then it's less steep once we get here. And then by the time we get to the top, it's actually flat, isn't it? Replace A with the coordinates. Work out the gradient. So no, unfortunately, replace A with the coordinates. Well, we're supposed to be replacing something with the coordinates, but unfortunately, it's not A, right? And this is where, do you recall last week, we had the discussion about what X and Y are. Do you remember when we started and we said that X and Y were input?
Replace X with 0, ma'am.
Put X with 0.
Yes. And then the Y is 4.
Okay, but we've already subbed in this point over here. We've subbed in. See, now if we put in 0 over here, what's going to happen to A? A will become 0 as well, and we won't be able to solve it. All right. So what we're doing, sure.
How wrong is it to say X has to be 2, because on that point it says
Well
2 to the 8 of the third, sorry.
No, you were right the first time. When you said that X has to be 2, you were right the first time, quite right. And that's because all coordinates, when they are written or given to you, let's just rub that out so we can and write next to it. All coordinates, when they are given to you, are given in a specific order. Always the X first. Sorry, and then the Y. So you were quite right. Okay, so what we're going to do is we're going to replace this X over here with 2, and we're going to replace this Y over here with 8 over 3, and then A is the only unknown. So when they give you the coordinates of another point that lies on the line, that's what they want you to do with it. Okay, so you're going to come along and you're going to substitute. You're going to replace Y with 8 over 3. You're going to replace X with 2. Remember grade 10s, when we substitute in brackets. We put exponents on the outside. Okay, and I hope you've all got your calculators handy because you're going to need it now. All right. What does 2 to the power of 2 give me?
4.
4.
Beautiful. Beautiful. Well done. Beautiful. 4A plus 4. All right. What are we going to do with this plus 4 over here?
Take it to the other side, ma'am.
Take it to the other side. Lovely. So take it to the other side for me and tell me what you get as an answer. Okay, so when I take it over to the other side, is it still going to be plus 4? Minus 4. That's
-4, ma'am.
negative 4, indeed. So everybody get your calculators. Okay, and you're all going to work out what 8 over 3 minus 4 is. And then you can either unmute or you can put it in the chat. It's up to you.
Negative 4 over 3.
Negative 4 over 3. Is that right?
Yes, ma'am, it's right.
That's right. Lovely. Is equal to 4A. All right. Well done. Now, 4A means 4A over 1. Does anybody know what I've got to do at this point? So I've got minus 4 over 3 equals 4A over 1. Can anybody tell me what I need to do here? Divide.
Divide both sides by 4 so that the 4 cancels the other 4.
100%. I've got to do that. But what about this 3 over here? What am I going to do with this 3? Has anybody ever heard of the method of cross multiplying? Have you heard how to cross multiply when you're solving for a letter?
Yes, ma'am.
Yes, you have heard that. Okay, all right. Well, that's encouraging. So if I say 1 times -4, I end up with -4. If I say 3 times 4a, I end up with 12a. Indeed. And now what am I going to divide both sides by?
4.
By what's in front of the A grade 10s. Okay, I've got to divide both sides by 12. Okay, remember you always divide by what's in front of the letter. Okay, it means 12 times what? -4. Now, this is the crazy part. Look at this. This is something that it's okay. What do you want to ask me?
So if you're saying we should divide by 12, or perhaps you say we should divide by what's in front of the A, is it wrong to divide by 4, or it just makes more steps?
No, it's actually wrong to divide by 4, because what would happen is this. If you had -4 equals 12a, and you decided to divide that side by 4 and you divided this side by 4, would you have solved for a?
No.
You won't actually, because unfortunately you're still going to have 3a over here, aren't you? So you're going to end up with -4 divided by 4, which is -1, but you've still got this 3 in front of the a. So you're still then going to have to divide both sides by 3 anyway. Okay, so if you always divide by what's in front of the a or the x or whatever letter it is, you're going to be able to go straight to the answer in your next step.
Okay, thank you, ma'am.
Okay, no problem. All right, so now a ends up being -1 over 3. Gosh, we didn't expect it to be a fraction, did we? But that's a really cool thing why we do this question, because it makes us realize that a doesn't always have to be an integer. It can actually be a fraction. Does it make sense to us that a is a negative? Were we expecting a minus number? Or do we think that because we've got a minus, we're wrong?
No, we weren't expecting a negative, ma'am.
We weren't? We weren't expecting
The graph,
a negative?
the graph
Yes.
is sad, so the answer has to be a negative.
Quite right. Well done. Perfect. So if we've got a positive answer here, we would look at the picture and we'd say, but hang on, it's wearing a sad face. There's no ways that this can be a positive. So we think that we must have the right answer. And indeed we do. Okay, so here, the equation of this particular parabola, it is the line y equals -1 over 3x squared plus 4. Okay. Now, the good news is that I did the more difficult question as the example with you, okay? So that you guys can do something that's a little bit easier by yourselves, all right? So I want to give you, unless there's any other questions, does anybody else want to ask anything? Okay, cool. I want to give you an opportunity to be able to do this, because obviously we always have to be mindful of our time. Okay, so it's exactly the same kind of question, all right? You've been given a graph of a quadratic function in the form y equals ax squared plus q. 2 points are shown on the graph, A, which has the coordinates 0 and -3, and B, which has the coordinates 2 and 5, all right? I would like you guys to be able to try and work out the values of Q and A by yourselves, okay? But If you don't understand or you need some assistance, please, 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 that's what I'm here for. All right. So let's see. I'm going to give you 2 minutes, and then we're going to talk about what the value of Q is if you think you know, right? And then if you know what Q is, put it in straight away and go on to A. But I just want to see if you can figure it out for yourselves. Okay, so let's do this. If you think you know what Q is, all right, pop it into the chat. Well done. Nasiso, you're right. Nhlafatso, hope I said that correctly. Perfect. Good job. Okay. Nice, Marisa, 100%. Okay. Is there anybody, and I mean, you can send a message to me by myself if you want to, but you don't have to be shy. Is there anybody who's really struggling with this? Is there anybody that's looking at this picture and saying, I don't know what Q is. How am I supposed to work out what that is? Okay, so no one's responded to me, so I'm guessing everybody knows what Q is. Does that mean everybody knows how to work out A? Okay, Naileti, no problem. Okay, you've got a problem working out A. Anybody else? You done, Inam. Well done. Okay, so we'll be with you now, Inam, and then I'll give you another one to do. Okay. Yes, Sayon, what's your question? No, A is not necessarily the same value as Q. You've got to calculate what A is. All right, Harrison, you're also finished. Zayan, you're also having trouble working out A, no problem. Okay, so let's do this. All right, well, I'm going to try and do this anyway. Now, see, I'm struggling. No problem at all. Okay. All right, so Zayan and Inam, I think it was. See if you can quickly write this down, and then you guys can work out A and or P and B and or Q, and then I'm going to quickly go back up to the top. In fact, maybe what I can do, I wonder if I bring that down. Is that too small now? I'm just trying to fit both of them onto the screen.
You can try putting the other one on the side.
That's actually a very good idea. You guys are so much better. Now, see, I put my answers over here. But that doesn't matter. Okay, like that. Hey, how's that? Can you see them okay? Sorry, doing a little bit of rearranging here. Okay, so if you are finished and you are feeling confident, then you can carry on with the picture that's on the right, the one that's got the blue parabola and the black parabola. Okay, so you are going to work out the values of A and P, and you're going to work out the values of B and Q if you're feeling confident. Everybody else who's not feeling confident, let's talk about the question on the left. Now, what I'm going to do is I'm just going to write in here. We knew that at A, the coordinates were 0 and -3. And we also know that at B, the coordinates are 2 and 5. So everybody was okay with the idea that Q was equal to -3. Q is the value of the y-intercept. Okay, that is the turning point of the graph in grade 10. So we would write y equals ax squared plus q. Let's just get rid of that. So subbing that in, y equals ax squared minus 3. Okay, and now this is the really important part. Okay, when you are given a pair of coordinates, it's always written with the x first. Okay, so that 2 is your x or your input. Okay, so in other words, that 2 matches up with that 2 over there on the x-axis. All right, and y is your output. Right, so y is going to be the number that matches up with the number on the y-axis. So I'm trying to do this in different colors. All right, so that's orange. All right, everybody happy with that? What I've got to do then is I've got to then go and replace the x in the equation with 2, and I've got to replace the y in the equation with 5. So my next step is to substitute. So y was equal to 5, so I'm going to let it equal 5. Then I'm going to replace what x was equal to. It was equal to 2. So substitute in brackets, put exponents on the outside, and now I'm going to finish writing down my equation. Okay, so that's the bit that you were struggling with a little bit. Does that make a bit more sense? So either you can pop that into the chat or...
Yes, ma'am.
You sure? Okay. All right, so now I want to see if you can work out what the value of A is. No problems there on. So you try and work out what the value of A is by yourself, okay? And just see where you can go from here. And even if you get the wrong answer, it still doesn't matter, okay? That's why we're here. That's why we're doing this course.
Oh, sorry.
It's okay, Tutuka. All right, and then the others are working on A and P. And if you're really, really snappy, then you would be able to do B and Q as well. Don't feel pressurized, okay? So there's always going to be extra work for people that are fast finishers. Yes, Nazal, no, hang on a second. No, there's no difference. You're done with all Harrison? Okay, no problem. Kelebogile, well done. Okay. I just want to go back to a question that I was asked. Where did you write that? There is no difference. We're going to go through the answers now, okay, grade 10s. There is no difference between y equals mx plus c and y equals ax plus q. No difference, right? But these are not parabolas. These are straight lines. Now, some books teach y equals mx plus c. That's the sort of older letters. And other textbooks in South Africa teach A and Q, and those are the sort of newer letters. But in this situation over here, M and Q mean exactly the same thing. So M over here, sorry, M and A mean exactly the same thing. They both refer to the gradient of the straight line. And C and Q mean exactly the same thing. So here, C and Q are both referring to the y-intercept of the straight line. Now, is y equals mx plus c the same as y equals ax squared plus q?
No.
Nope, definitely not. Okay, so these two over here, all right, are not the same. This x here is x to the power of 1. This x here is to the power of 2. Okay, so when it's to the power of 1, it's going to make a straight line, a diagonal line. And in y equals ax squared plus q, it's going to make a parabola. Okay, so now let's go back and let's have a look at the answers that you guys got. All right, so Kelebogile told me that a was equal to 2. Did anybody else get the same answer as Kelebogile in the question on the left?
Yes, ma'am.
Yes.
You did. Okay, brilliant. So in other words, you all hopefully went 5 equals 4a minus 3. You took the minus 3 over to the other side and you said 5 plus 3 is 4a. So that means that 4a is equal to, whoopsie daisy, what am I doing? Is equal to 8. And then we divided both sides by 4. Okay, remember the number in front of the a, that's what we've got to divide by. And then we get 2. Okay, so big round of applause to all of you who got 2 as an answer. Okay, that was 100% correct. Okay, do you see what I mean now when I said I did the more difficult one as the example? And then I let you guys try the easier one on your own. All right, now let's go over to the other side. I'm not sure. Are there any, so hang on a second. Are there any questions? Is there anybody who wants to know where the 2 came from or why it's like that? Are we all happy? Okay, so if no one's saying anything, then I will. Yes?
Where did the 4 come from? If you look closely, you said 5 equals to a 2 squared minus 3. Then on the next line, you said 5 equals to 4a. I just want to know
100%.
just some clarity on that.
100%, no problem. All right, so what I was saying over here, remember, you actually even read it out beautifully. You said 2 squared, 2 to the power of 2. Okay, so 2 to the power of 2 needs to be multiplied with a. So if I write a and then I write a bracket and I write 2 to the power of 2, I have to follow the laws of BODMAS. And BODMAS tells me that I first have to square my base and then multiply by anything else. So 2 squared means 2 multiplied by itself, which is 4. And 4 times a is 4a. Does that help?
Thank you, ma'am.
Pleasure. Okay, so now, sorry, was it, hello?
Is it always advised to work inside the brackets first while doing this, or you just have to do the BODMAS way?
You should always raise a power to a power first. So let's say, I mean, if you were working with something that was a little bit different, so let's just change this. And let's say that you had something like 3 times 2 to the power of 3. Okay. If you don't follow BODMAS, you're going to get the wrong answer. It's kind of like if you're driving on the road and you go through a red robot, then you're going to get into an accident, right? It's because you didn't follow the rules of the road. It's the same story with us. So if you don't follow the rules of BODMAS, you're going to have an accident. So BODMAS says to us that we have to do exponents first. So here, this 2 that I'm underlining is my base. I have to say 2 times 2 times 2, 2 cubed first, and then times my answer by 3. So this would end up being 3 times 8. and then I can say 24. All right, if I say 3 times 2 first, I'm wrong because I can't multiply before I do my exponent. And if I ended up with 6 to the power of 3 and my answer was 216, that would be wrong. Okay, so order is important here. So if you've got a number in a bracket and an exponent, do the exponent first and then times by the letter. Okay, it's a pleasure. It's an absolute pleasure. I hope this is making sense. Okay, so now those of us that were able to have a look at A and P and B and Q. Harrison, I recall you saying that you were able to do both. Would you be so kind as to share your answer for A and P with us? Because I want to see if you got the same, well, I got the same answer as you. Are you happy to do that, Harrison?
Yeah, it's not a problem, ma'am. My
Cool,
A
thank
is
you.
positive. My A, the answer I got for A is positive
Yes.
1. And then the answer I got for B, it's negative 1.
Okay, so I got for A, can you see, is that a little bit small? Can you see that? Don't know if I made a mistake here, Harrison.
Where?
Okay, for P, I got -9.
Yes, same.
Same. Okay. Cool. All right. So for P, I got -9, and for A, I also got 1. All right. So Harrison, that was perfect. All right, 100%. Nazol, I'm going to answer your question right now. Is there anybody else besides Harrison that was able to do both? If you didn't, don't stress. Was anybody else able to get A is equal to 1 and P was equal to 9? Okay, no stress. All right, now Harrison, so this is for you, and then we've got to answer Nazol's question. Don't know if you managed, I hope I got the same answers as you and that I didn't make a mistake. So Harrison, in the SAD graph, I got Q is 23 and I got B is -1. What did you get?
Okay, in the set graph, my Q is positive 23, yes. And then my P is negative 1.
Wow, Harrison, that's brilliant. Okay, very nice. Okay, so I got the same answers as you. So that's brilliant. That's great. At least we know we're on the same page there. Okay, everybody else, if you didn't manage to do this, it's not the end of the world. There's always going to be work for people that are fast finishers, as I said. Okay, so now I just want to have a look on the chat. Nazol, you said, in what situation would you calculate the gradient to find M or A? All right, so Nazol, let me just move my graph over here or the page over here. I'm going to draw a set of axes quickly. And then I'm hopefully be able to explain something to you. So Nazol and everybody else, because I'm sure if Nazol's asking, a lot of people have got questions like this. Nazol, when you are working with y equals mx plus c, or y equals ax plus q, these can only be diagonal lines, right? So when I say a diagonal line, I mean a diagonal line like that. Okay, so now this diagonal line can either be slanted up to the right-hand side or not. Okay, so if you can imagine, there we were down at the bottom over here. If we now want to go there, are we walking uphill or are we walking downhill?
Uphill.
We're walking uphill. But now when I walk from here to here, is it steeper than if I walk from here to there? Is the graph getting steeper? Is it getting harder for me to climb?
Yes.
Yes, ma'am.
You think so?
Yes. Yes,
Okay. Unfortunately, it's not. The steepness is not changing. The steepness is still the same. All right. It might be harder for me to climb because by the time I get up to the top here, I'm absolutely exhausted. But it's not steeper here than it is there. The steepness is the same. Oh, shame. And Tab is saying, it's unfortunately it's 6 o'clock. We've run out of time now. But what we can try and do is next week we can see if it's possible for us to be able to do that. That's fine, Kelebohile. Don't stress, not to worry. Okay. What I just wanted to say quickly before we go, and unfortunately we do need to leave now. This is a very badly drawn parabola. But the reason that you can work out M and A here is because the steepness of the line is not changing. Whereas here, the steepness of the line changes depending on where I am on the line. So in other words, if I'm all the way down at the bottom over there, it's very steep. But by the time I get here, it's not so steep anymore. When I get here, then I'm not climbing up and I'm not climbing down. But again, the value of A is now changing. All right, the gradient is going to change. Sorry, not the value of A is going to change, but the steepness of the line is going to change. All right, so when we are calculating M and A on a straight line, that's for gradient. Okay, that's why in y equals ax squared plus q, A is not gradient. Okay, A is not gradient. Remember, A tells us about the shape of the graph. It's either happy face if it's positive or sad face if it's negative. Okay, A is not gradient for a parabola. Anyway, I think I've gone a little bit over time. I'm sorry, Tula.
No, it's okay. This
Beg your
is what
pardon,
we're
sorry.
here for after all.
Absolutely.
Are you done now, Lee?
Unfortunately, no, I'd love to carry on teaching, but unfortunately it's 6 o'clock and I realized that was our cutoff time. I'm just a little bit confused, a little bit concerned because I just feel bad now because Kelebohile, she says, ma'am, I tried doing the other two, but I'm struggling. Nolwazi is asking, is this on the app? But it's not. Is there any way that we could put these questions? I suppose there's no ways we could put them on the app, is there? Sorry, anyway, Tula, you take, sorry, I beg your pardon, you take over, Tula.
Hey everyone. Yeah, no, unfortunately we have run out of time. But I think you guys will be doing functions for the next few weeks. So I guess possibly, I don't know if you could find a way to circle around these kind of questions because I'm sure they form the basis for the next few lessons. Yeah, I'm sure we would find a way to figure that out. Hey everyone, I really just came in without saying hi to everyone. Again, my name is Tula. I am a mentor with Watobi Maths, and I think you guys have got the hang of everything really. So I'm not even gonna take a lot of time. I just want to let me just share my screen real quickly. Yeah, this is just what I want to show you. I'm just going to remind you of this every single lesson that we have, just so you keep in mind that for this series now that we're doing the functions and graphs, it's a total of 8 lessons, and we just finished our second lesson now. It's ticked off. I like ticking it because it's a vague feeling of achievement. And then next week, I think this will be on Tuesday, the 3rd of August, we're doing quadratic functions, the application of all of this. So I'll see you guys all there. It's always great to see new faces. I'm seeing a lot of new faces now, but it's even greater to see the same people coming back because then your knowledge is building from what you learn here, and you're actually solidifying your maths. And yeah, remember, we also have the app, and on the app, we want you to go to the app to keep practicing the things that you learn here, to keep applying. And I'm happy that you guys keep on asking, is this on the app? Is this not on the app? Because it shows that actually when you go from here, you go back to the app and you try to practice everything that you've learned here. So I know I promised you guys, for those who remember, I promised that we'd do the leaderboard today, but we want to give you guys a little more time to do as many apps as you as many activities as you can. So we'll do that next week. And for those who don't know, remember that the leaderboard, we basically we're going to have 3 or 4 learners, if I'm not mistaken, who did the most activities over the week. And I want to try to emphasize that this is not about who got the most right. It's not about you being perfect in maths or knowing everything. We just reward people who did the most. So it's about trying. It's about the effort. It's about, doing the most activities and just, trying to understand as best as you can. Let me stop sharing now. But yeah, if Lee doesn't have anything to add, I think we can let you guys go now to enjoy the rest of your evening. That's it from me. Thank you guys for joining us. I'll see you guys on Tuesday.